So let's continue in number 9. You have known that which of the following is not correct to the nearest hundreds. Sine 75 degrees, if you're going to type it in the calculator, it would result to 909.96592 or 0.97, which is also true in our given. Let's have letter B. Sine of 37 degrees, if we're going to input that in calculator, that's equivalent to 0.75, which is also true in our given. Let's have letter C. If we're going to input C, tan of 18 degrees, that is equivalent to 0.32. But here it is 0.23. That makes no sense. Now letter D, let's try letter C. Cos of 46 degrees, it will result to 0.69 nearest degree. So that would be 0.69, which is also true. Hence, our answer is letter C. Tangent of 18 degrees is equal to 0.23, which is false. Now let's have number 10. Number 10 states that if a secant squared A is equal to 5 halves and 1 minus secant squared A, what is 1 minus secant squared A? Sine squared A. Now in a super hexagon, secant squared A should be equal to 1 minus sine squared A. We can solve this using our identities by using our super hexagon if necessary. Now we have secant squared A. We all know that 1 minus sine squared A is equal to cos squared A because 1 is equal to cos squared A plus sine squared A. Now secant squared A is equal to cos squared A. And also cos squared A is equivalent to 1 over the secant squared A, right? Now, after that, we already have this. This is already equal. Not equal, but the same identity. We can substitute the value of secant squared A, which is 5 halves, to the secant squared A in the other equation, in other side. So 1 over 5 halves, if we're going to calculate that in calculator, 1 over 5 halves is equivalent to 0.4, which is letter C, is our answer. Now let's proceed to number 11. Let's have 11. In number 11, it states that cos A to the power 4 minus sine A to the power of 4 is equivalent to, let's have this expression, this one I mean. Now, since this one conformed as a factor, we can factor this into cos squared A minus sine squared A and cos squared A plus sine squared A. Since we all know that in our identities, in our super hexagon, we can know in as Pythagorean identities, this is equivalent to 1. So we have only cos squared A minus sine squared A. Now in our rule here that we have double angle formula, that cos squared A minus sine squared A is just equivalent to cos of 2A. Hence, our answer is letter B, cos of 2A, which is letter B. Now let's have number 13. What is the correct ratio for sine A? Now what is the correct ratio for sine A? We are given that a sine, I'm so sorry for that, but in number 12 it states of what quadrant is A if secant A is positive and cotangent is negative. So we need to find quadrants that equates that secant A is positive and cosecant A is negative. We know that secant here is positive and cosecant is positive, and negative secant theta and positive cosecant theta in quadrant 2. In quadrant 3, they are all negative, and in quadrant 4, positive secant theta and negative cosecant theta. Since we are tasked to find what quadrants that make secant theta positive and cosecant theta negative, we have to find here. Remember, it's in quadrant 4. Hence, our answer is in quadrant 4. Now let's move on to number 13. In number 13, it states that what is the correct ratio for sine A? So, given the figure, the ratio of sine A, this is the theta, and we all know that sine is equivalent to the opposite of hypotenuse. Since our opposite here is 12, then substitute, and our hypotenuse is 13, substitute. Hence, we can find our ratio here, 12 over 13, which is the letter B. In number 14, we have the question, find the value of sine times arc cos of 15 over 17. We need to find the value of this. Now in calculator, input sine, just sine. That would automatic close parenthesis. Input shift of cosine because the asht here is the degree. So, and this is not a degree. So we need to put shift cosine over 15 over 17, then close parenthesis and close parenthesis again, so that it will not be in syntax error. That's equivalent to 8 over 17, which is our answer, letter D.